And this program just outputs hello world. 11 characters, nothing fancy. Also, its size is not particularly big. It's 62 bytes of C code. However, when I compile it, Linux makes it a monster. You see? Pages after pages after pages of binary data. Why is this? Is Linux trying to steal my disk space? Or better, what can we do against it? How can we remove libraries and how can we tailor it to our needs so that it gets smaller? And how small can we get? Let's find out in this video. I'm using the normal way of printing hello world. I use printf. It comes from the standard input-output library and everything should be good. However, printf is huge. It cares for formatting, it cares for localization, and all this gets baked into our code. And when we compile it, for example, with this command, then we see this, it has 16,000 bytes. The resulting binary has 16,000 bytes, just for outputting 11 characters. Now, what printf will do is a syscall write. And the syscall write is a system call to the kernel to output something onto console. It cannot do it itself because it is not privileged. Only the kernel is privileged to access the console, to access any kind of hardware or infrastructure. So printf does nothing else but does nothing that is of our interest except for a syscall write. Can't we write this on our own? Yes, we can. And we can also do it in C, but that would not look tidy and there would be nothing to learn there. So I'm writing it in assembler here. So here we have a new version of our hello world program. First, there's a data section, which contains hello world plus a new line. And then there's a code section that will be executed. It moves the value 1 to the register AX. And this signalizes to the kernel, yeah, please write this. What shall I write? Where shall I write to? Yeah, that is in the register DI. And where's the pointer? That is in the register SI. And the length is also in a register, and that is EDX. And then it just does a syscall. Syscall will find out, oh yeah, I'm about to write something, and will then output the message. Afterwards, it will terminate itself. So the program will gracefully exit. This is what this program does. And let's see what happens when we compile it. This is the command to compile it. Then we still need to link it. And now we have hello2.bin. When we execute it, it gets output, this time with a new line at the end. And when we list its size, we see it has been reduced. It has been cut in half. It's only 8.3 thousand bytes now. 8,300 bytes. That sounds like two sections of 4,096 bytes, because we have sections here, one section for the data and one section for the text. Let's do it with one section. So text means this is the code, and we don't really need a specific data section here. So we remove this here, save it, and compile it again. And we see it is now 4,300 kilobytes big. I'm afraid we won't get it much smaller because Linux needs ELF files, executable linkable files to be executed. And also it's not our code that fills 4,300 bytes here. It is needed for the structure of the ELF file. So if you want to go smaller, then I have a great idea. You could watch my next video where I show how to create your own bootloader and writing hello world there.